Greetings, everyone. Frasian Nation. Once again, we're in the geometry series, and we are trying to flip this young classroom this year. You have to give me credit where credit is due. Let's go ahead and throw all these lectures up there. So if you missed it, if I went too fast, you can go back, pause the video, make sure you have everything you see on the video in your notes. So I know you guys remember the note on the board where it says if it's on the Promethean board, it's in your notes. Well, I know you don't see my finger tapping, but if it's on the screen, it needs to be in your notes. So anyway, let's go ahead and get it how we live. 1.2, use segments and congruence. Okay, so the main objective that we want you guys to be able to do is students will be able to calculate segment length using the segment addition postulate. Okay, I want you to think about that for a second. In geometry, it is always in the name. So look, we are talking about the. Here we go. I need a highlighter. Let's get a highlighter going here. Okay. Students will be able to calculate segment lengths using the segment addition postulate. Okay. So that's basically saying we're going to take and add segments. Basically the distance of the segment, but still we're adding segments. So let's go ahead, get a pen tool going. Essential question. What are congruent segments? Well, at the end of this lesson, hopefully you'll be able to answer that question. Few things we need to remember and review. I want you to remember these signs. Remember, if it's a miniature line on top, that means that we're talking about a line AC. If it has no arrows on top, this is a miniature line segment. So that means line segment AC. When we have a miniature ray up top, remember the end point is the first letter. So we have ray AC and we have ray CA. And I should have did some bullet points. So bullet points and bullet point. Collinear, same line, point. So point, same line. Okay, next. This is really not that important until later on down the road, but we do want to throw this at you. When we have postulate or we have axiom, okay, these are the same. These are the same words, basically same interchangeable meanings. Different words, interchangeable meanings. A rule that's accepted without proof. Okay, so something like the Pythagorean theorem, where you have A, B, and C, we can prove that. If we're saying something like, well, a point is represented by a dot, I really can't prove that to you, but I just want you to roll with it. I want you to go with that. Okay, so anytime I have a postulate like the segment addition postulate, then I want you to just go with it and just move forward. Coordinate, the real number that's attached to a point. So let's go ahead and get a little example going. Can't seem to click on my pen tool. Okay, so and let's get black. Okay, so if I had a line, a number line, okay, and let's see, let's do some dashes like this, and let's put a dot right here. So if I said that this was 5, and this dot right here, that would be 2. Let's see, so let's make this 0. So if I have a dot, okay, and there's a number attached to it, these are your coordinates. So this point has coordinate 5, this has coordinate 2, this one has coordinate 0. Okay? So next key vocab, and I gave you the book definition and I gave you the kind of short and sweet way to say it. You can go ahead and write this down. This is really key right here, okay? I'm going to go ahead and instead of circling it, I'm going to go ahead and highlight it, okay? Let's highlight in blue. Okay, let's do it a little bigger. Um, this is really important, and I feel like a lot of you guys missed this in our initial lesson. The symbol is AB. Okay, so whenever we say, like, for example, if I write this down and I say find BE, okay, you need to be able to tell me that, hey, these are 2 points. I'm trying to find the distance between the segment of B and E. Okay. There's no symbol up top. Okay. There's no little miniature like line or ray up top. This means a number. Okay. So I would take the coordinate of B. I would take the coordinate of E. I would subtract and find the absolute value. Do you guys remember absolute value? It's any number that I give you and out pops the positive number. So if I had the absolute value of -5, I would have 5. If I had the absolute value of -13, this would be 13. If I have the absolute value of 8, this would be 8. So absolute value, no matter what's inside, out pops the positive value. Okay? Next card. Between, okay, not really all that important, but it can be useful. So first and foremost, here's a condition: you need 3 points that are collinear. If you don't have 3 points that are collinear, this really makes no sense. So if I say 3 points are collinear, here's point A, B, and C. 1 point has to be between the two. So as you look, if I said A, B, and C are collinear, B is in between A and C. Okay. And finally, we're going to kind of introduce a couple of ideas in this next key vocab. Congruent segments. Fraser, slow down. What is congruent? Well, in geometry, we're going to use the word congruent, which means equal, which means the same, okay, in geometry a lot. We're not usually going to say equal unless we're like actually doing an equation. So I want you to look at this symbol, okay, and let's go ahead and draw that out. So you would do a equal sign and then put a little tilde up top, okay? So in a diagram, here's line segment AB, here's line segment ECD, and here's line segment EF, okay? I have 3 line segments, and in a picture, in order to tell that AB and CD have the same length, we put dashes, okay? So AB has 1 dash, CD has 1 dash, EF has 2 dashes. So what does that mean? EF is not the same length as CD and AB would be, okay? So as you see, I've written out the little statement. Line segment AB is congruent to line segment CD. Questions? Next card. Okay. This is, like I said, this is kind of the technical definition that the book gives you. I like to keep it short and sweet. So here's line segment AB. Here's line segment BC. Once we put them line segments together, the whole line segment is your measure. So I would write down, let's write it down over here, 2 small segments are going to be equal to the big segment, okay? Two small segments are equal to the big segment, okay? This is something I remember. All right, let's go ahead, get a little guided practice going. Go ahead and draw your diagram first, okay? And it says here, use the segment addition postulate to find XZ. So let's go ahead and write this out. Let's go ahead and write this in blue, guys. Okay, so I said that, flip it around. Let's say big segment, okay, is equal to the two small segments. Okay, so here's the big segment, xz. So write that down. We got to use an equation. So xz, okay, and notice there's no symbol up top, so I'm talking about the distance between x and z. The distance between x and z is equal to the two small segments xy plus yz. Okay? I'm going to set this up to show you like this is just a simple substitution and equation from Algebra 1. So we don't know what the big segment is. Let's just pretend we don't. And so let's put xz again. And xy we know is 23. So put your 23 down. And then your yz is 50. Okay? So in Algebra 150, we would say, hey, we have two like terms right here. We have numbers without the variable. So we didn't do anything to the left side of the equation. So we have xz. And then on the right side, when we combine like terms, we have 73. Okay, so this is our answer. So let's do a little star. Yay. Okay. In geometry, and this is something I need you guys to get familiar with, we're going to use the same diagram. Okay? But I want you to notice something. It says in the diagram, wy is equal to 30. Well, here's wy. There's no 30. So what do? You need to go ahead, throw that in your picture. Okay? So wy is equal to 30. I want to know, can I use the segment addition postulate to find the distance between w and z? So can I find this distance? No. Well, why not? Explain your reasoning. Well, I'm going to say no. Okay? Because I'm looking like segment addition postulate, segment addition postulate. If you look between w and z, there is no segment. How can I find the distance of this segment when there is no segment? Okay, so I want you to remember collinear, okay? In between, you would have to say no because y is not between w and z. Okay, y is not between w and z. We have no segment, so we can't even use the segment addition postulate. Okay, number 3. This might be easy to some students, hard to others. Let's go ahead and think about big segment is equal to 2 small segments. Okay, 2 small segments. Okay, so the big segment right here would be Vx. Okay, 2 small segments would be Vw and Wx. So as you look at this picture right here, Vw, Wx is like 2 sticks. If you put them together, they make a big stick. Okay, now let's fill in what we know. We know what Vx is. Okay, the picture tells us that is 144. Okay, we know Vw is 37, and we don't know Wx. And I mean, seriously, it says find Wx, so we don't know it. This is Algebra 1, people. We have a positive 37. We need to combine like terms, so we need to use inverse operations. We want to cancel this 37, get Wx by itself, and when we use inverse operations, we have to go on both sides of the equal sign. So once I have 147 minus 37, we have 107. And I kind of want my thing on the left. I have here Wx is equal to 107. Ooh. So if I would put 107 right here, that is not a 7. That is not a 7. That is not a 7. Okay, if I were to put a 107 here, then hey, this is what I was saying. 37 plus 107, put these two sticks together, and you get 144. Okay? Let's go ahead and look at your homework. Let's look at your practice problems, and let's get familiar with 1.2. See ya!